In this video, I will show you how to multiply and divide values in scientific notation. Here are steps for multiplying in scientific notation. Multiply the coefficients, multiply the powers of 10, which means keep the base and add the exponents to tell us how many tens there are, and then adjust the decimal point and powers of 10 to write in scientific notation if necessary. I'll do two examples for multiplication. In the first example, the first thing I'm going to do is multiply 6.5 times 200. 6.5 times 2 is 13, and since it's really 200, it will be 1300. If I wasn't sure about that, I could do the calculation over to the side. I typically write the longer number up top, and then I'm going to be multiplying 5 times 0, 5 times 0, 5 times 2 to give me 0, 0, and 10. Then I put a placeholder 0, and I multiply 6 with each of the numbers above. So 6 times 0 is 0, 6 times 0 is 0, 6 times 2 is 12. That gives me 13,000, but since there was one digit to the right of the decimal point, I'll need to move the decimal 1 in from the right. I also could logically think that 6 times 200 is about 1200, so I need to be in the same place value. Then I'll multiply my powers of 10. 10 to the 4th times 10 to the 5th is 10 to the 9th. We keep that base and add the exponent. We check to see if we're done, and we're not because we know that we need this to actually say 1.3. We can't have more than one digit to the left of a decimal point in scientific notation, and we already have our decimal point implied right here. So I'll move this 3 places smaller, and therefore I need 3 more powers of 10. So my final answer is 1.3 times 10 to the 12th. Feel free to pause the video and try the next one on your own, or do it with me. 1.3 times 24, I'll do over to the side. 1.3 times 24, 3 times 4 is 12, 3, so carry the 1. 3 times 2 is 6, so I need to write 7 because I had to carry the 1. Put a 0 as a placeholder because we're not really multiplying 1, we're multiplying 10. 1 times 4 is 4, 1 times 2 is 2. This is 312. However, once again, I need to move my decimal point in one space because there was only one digit in each of those two factors to the right of the decimal point. So I have 31.2 times 10 to the 11th, and I got 11 by adding together these exponents. Maybe you even want to write here, add, so you remember to do that with the exponents. Adjust this to be from 31.2 to 3.12, making that smaller. We need to make this exponent bigger. You could write 10 to the 1st, or you could do a little plus 1 like I did. I want to show you both strategies there. 3.12 times 10 to the 12th. Now we're going to do some division. In division, don't forget our rules that we cannot have any fractions. We can only have decimals. Everything has to be in the numerator. So here are our steps. Divide our coefficients and write as decimals, no fractions allowed. Divide the powers of 10, which means keep the base and subtract the exponents, but I'm going to show you a way to rewrite those powers of 10, which I think will make it easier, and then we adjust into scientific notation. We'll do 3 problems together, and I'll show you the second one 2 different ways, so I'm just going to copy and paste this problem twice, and you can decide which way to copy down or both. So I basically think of this as separate problems for each part of this here. The circles sometimes get in the way, so I like to draw arrows. 30 divided by 5 is 6. 10 to the 7th divided by 10 to the 4th is 10 to the 3rd. I can visualize writing out 10 7 times in the numerator and 10 4 times in the denominator and crossing off and being left with 3 factors of 10. Or I could subtract those exponents. 7 minus 4 gives me 3. But my favorite way to do this is to cross off 10 to the 4th and write it as 10 to the negative 4th in my numerator. Once all my 10s are in my numerator, I know that I can add my exponents together, and I find that we make fewer errors that way. On the next problem, I need to first do 0.3 divided by 5. You could do long division for this. 0.3 inside, 5 outside. 5 does not go into 3, so I'll bring my decimal point straight up and I'll write a 0. And I put another 0. 5 goes into 30 6 times. That goes in evenly, so I'm done, and I get 0.06. Then I need to figure out my exponent. 10 to the 3 minus 6 gives me 10 to the negative third. I again prefer to cross off 10 to the 6th and write 10 to the negative 6 here so that then I can add these and I make fewer errors. I'm not yet done. In the first problem, 6 is the same thing as 6.0, so I was done. Versus here, I need to adjust this 2 place values bigger. So I would adjust this by either writing a minus 2 here or a 10 to the negative second here. So I get 6 times 10 to the negative fifth. I have a different way that I prefer to do this problem. I don't like doing long division, especially with decimals. So I look at this problem and I say, instead of a 0.3 right here, I would rather have a 30. So if I turned that into a 30, I've made this bigger by 2 place values. So I would need to adjust this smaller by 2 place values. And the reason for that is that this numerator, in both cases, is the value 300 if I wrote it in standard form. Right here I would adjust it 3 places. Here I would adjust it 1 place and make it 300. The reason why I prefer this is now I can use mental math and I never had to do long division. I have 6 from 30 divided by 5, and I have 10 to the negative fifth from 10 to the first over 10 to the negative sixth, or again, I could cross this off and bring it up as 10 to the negative 6 here if I prefer. One more problem. So I can simplify this here to 1/5, but again, we're not allowed to do a 1/5. So I probably would just simplify it here as 1/5 and then know that 1/5 is 0.2. And if I didn't know that, I would do some long division. 1 divided by 5, we have a 0, and then 5 goes into 10 2 times. Here's where the exponents get tricky. So I could do 7 minus negative 4. I see a lot of errors there with people doing 7 minus 4 and writing 3. And that's why I encourage you to cross off 10 to the negative fourth, write 10 to the fourth up in your numerator, and then we can make that 10 to the 11th. Make this 1 place value bigger, make this 1 place value smaller. We get 2 times 10 to the 10th as our final answer. So our steps there was that we had to convert 4/20ths into a decimal, which was 0.2. I found it easier to first make it 1/5. Then we had to figure out our powers of 10. 10 to the 7th over 10 to the negative 4th is actually 10 to the 11th. Then we had to adjust this decimal point in scientific notation, and if I make part of the number bigger, I have to make the other part of it smaller to maintain that same number. So those are some quick examples for multiplication and division in scientific notation. One side note that you might find helpful is that if you were doing a problem like this, 3 times 4 times 10 to the 8th. Well, there isn't another part of this 3, right? It is 3 times 10 to the 0 if you wanted it to be that. But you could even kind of ignore that part and just do your 3 times 4 still to get 12. 10 to the 8th stays 10 to the 8th. We don't have any other 10s to combine it with. And then we turn that into 1.2. So this is 10 to the 9th. Thanks for watching.